All right, this lesson is on relations. The objectives are we will be representing relations, and then we will interpret graphs of relations. There's several vocabulary words in this, and we will talk about most of these as we go through the lesson. The first 2, 4, 6 are all about graphs, the coordinate system, coordinate plane, x-y axis, origin, ordered pair, x and y coordinates. It's all on a regular graph. Then relation is just a set of ordered pairs. We'll talk about mapping, domain and range, and independent and dependent variables. So take some time and check mark the ones that you know, and maybe you'll understand more as we go along. All right, so here is a relation, a set of ordered pairs, and it's in set notation with the curly brackets, and each of the ordered pairs separated by a comma. We're going to represent them in 3 different ways: as a table, a graph, and in a mapping or a mapping diagram. When you're representing something in a table, you will list the x coordinates in the first column and then their corresponding y coordinate in the second column. So we have a 4 for x, and its corresponding y coordinate is 3. And then -2, -1, 2, -4, and then 0, -4. It's that easy representing something in a table. We can also represent this on a coordinate plane, coordinate plane. But let me first grab these. I forgot to copy them over there. All right, so there we have our ordered pair, and remember that ordered pairs, when you are graphing on the x and y axis, the coordinate plane, the x coordinate is first and the y coordinate is second. Remember that y is positive going up and negative going down, and x is positive going to the right and negative going to the left. So the x-axis, the y-axis, and the origin is 0, 0. So we go to 4, to the right 4 and up 3 represents the point 4, 3. Then to the left 2 and down 1 represents the point -2, -1. And then to the right 2 and down 4 represents the point 2, -4. And then when we have 0 for either x or y, you'll be at the origin, and if x is 0, then you'll just move up and down, and if y is 0, then you'll just move left and right. So 0, we don't move, and then we'll go down 4 to represent 0, -4. And then finally, we will represent this in a mapping diagram or a mapping. Domain are the x's, and the range are the y's. I always think about alphabetical order. Domain comes before range, D comes before R, just like X comes before Y. And also, because we're going to be talking about independent and dependent variables, the independent variable is always the X, and the dependent variable is always the Y. So when we're doing a mapping, you'll list the X coordinates under the domain, so 4, -2, 2, and 0. And then we're not going to repeat anything in the range. So we have a 3, a -1, and we have 2 -4, so we're going to just write that once. And then with mapping, you will connect your domain with your range with an arrow pointing to the number in the range. So 4 goes with 3, -2 goes with -1, 2 connects to -4, but also 0 connects to -4. So those two numbers will be pointing at the same number, and it also works the other way. If you have repeating x values, then you will have 1 going off of, maybe it's a 2 would go to -1 and -4. Then we would connect the 2 to 2 other numbers in the range. All right, so take a moment. Oh, first of all, we need to change the numbers. Okay, so I've repeated these same numbers from the first problem. These are our new numbers right here. We're going to use 5, 1, negative 3, 0, negative 3, 1, and 2, 7. So at this point, pause and put those numbers in a table and then restart and see if you've got it in the right, them in the right spots. Okay, so checking, you should have these numbers 4 or 5, 1, negative 3, 0, negative 3, negative 1, and 2, 7 into the table. All right, we also have some numbers we're going to represent in mapping. So take a moment and pause and fill out the mapping. Remember, domain are your x's and the range are the y's. Okay, so you should have these answers. You should have no repeats on anything. And so it's similar to the table. You just have arrows connecting the domain to the range or the x's to the y's. All right, and then here's one where you are graphing. So take a moment to graph these 4 sets of coordinates and then come back and check your answers. All right, so you should have 1 coordinate in the second quadrant, 2 coordinates in the first quadrant, and 1 coordinate in the fourth quadrant. All right, independent and dependent variables. The independent variable changes the dependent variable. Often time is an independent variable. So, and these in an equation, these would be your x's, and and the dependent is your y's. Time is a good example of that. Temperature is one that could possibly change. Anyway, but time is a really big one as an independent variable. So what I like to do is I go through and I highlight the things that I see. It says in warm climates, the average amount of electricity used rises. So the electricity is changing as the daily average temperature increases. So that's my clue right there. It says this is rising as the daily average temperature changes. And then it changes when the daily average temperature decreases. So identify the independent and the dependent variables. What is changing? The electricity use is changing, and it changes with the temperature. So that means the electricity use is the dependent variable, and it depends upon the average daily temperature. Okay, as the average daily temperature increases or decreases, that is your independent variable. So I just like to abbreviate and put I and D. And independent variable is the average temperature. And we could put daily temperature. And the dependent variable is the electricity used, or the amount of electricity used. Okay. All right, so take a moment and read this next problem. The number of calories you burn increases as the number of minutes that you walk increases. Look for that as the, and that's your indicator as to which one is the independent and which one is the dependent variable. Okay, the independent variable is the number of minutes that you walk, and the dependent variable is the number of calories that you have burned. The last thing we're going to look at is analyzing graphs. Graphs representing, this graph here to the right represents the temperature in Miss Ling's classroom on a winter school day, and it describes what's happening. Well, here's the beginning of the day, and I don't know about you, but when I get up in the morning, first thing we do in the winter is we turn our heat up, so the temperature increases. So I think about that in the classroom. The temperature was low overnight, but then the temperature increases, and then what happens when it gets to a certain point? Your thermostat says it's time to shut off the heater, and so then it gets a little colder, and then the furnace kicks on and it warms back up, and then it turns off and it cools back down. So it goes back and forth, and it fluctuates back and forth between a temperature that's controlled by the thermostat, and then at the end of the day the heat gets turned back down and the temperature goes down. So how would we describe that? Here's a sample answer. The temperature increases after the heat is turned on, then the temperature fluctuates up and down because of the thermostat. Finally, the temperature drops when the heat is turned off. So that is a sample answer. You can definitely condense that down, but you understand what is happening, what is processed. If the heater stayed on all the time, the temperature would increase. If the heat is turned off, the temperature would decrease. That's why it kicks on and off throughout the day. Same thing with air conditioning. And that is relations.